Welcome to this tutorial where we will discuss about Bash and the possibilities that it offers to create data structures. We'll cover from the most simple data structures like indexed arrays to associative arrays to the possibility of creating custom data structures to suit individual needs. So we will just start right away by covering reference variables. Reference variables we have previously covered already the declare built-in command, and that it can be used to create variables in general. And it's also possible to use the declare command to create references. So basically what references are, to make an analogy to other programming languages like C, for instance, it would be the closest thing to a pointer that Bash offers. So let's consider, for instance, in the example, the variable name that is being declared here to the value Bob. And we want to declare another variable that will point to that first variable that has been created. So that is what references are for. And to create references, the option of the declare command that can be used is the -n option. So with the -n option, it implies that the value of that variable is referring to another variable. So basically, instead of using the variable, it's possible to use the reference instead. So to apply the principle of this reference variable, you just declare, for instance, a variable name and set its value. In this example, I just set it to Thomas and just declare it's not a variable with the -n option, meaning that that variable would be a reference. I'll just name it ref, and we'll set its value to the value name. So name here is referring to the variable name that has been created in this first part. So with the dollar and brace expansion, I could, for instance, show the contents of the variable name like this. And then we have name column Thomas. But the reference also refer to this name variable, or rather I would say it's pointing to this name variable. So instead of using the name variable, it would literally be possible to use the reference instead, and we'll just have the same variable name. So every time that Bash encounters a variable that has been flagged as a reference, it implicitly gets the value from the variable that is being referred to by this variable. So in comparison to C, it's something like a pointer, but without all the complete flexibility, yeah, of the C programming language. Indexed arrays with the declare built-in commands, it's also possible to create indexed arrays. And the option for creating indexed arrays is the -a, also in lowercase a option. We need then to specify the name of the variable, as always, and list the values that we want to be part of the array between parentheses, and each value separated from the other with a single space or a space or white space to be more general. So I could declare an array, a lang array, for instance, in this case, where its value would be C, C++, Python, Bash, JavaScript, the PHP, and so on. So basically, this variable lang is an array, and that array contains a list of programming languages. To get the elements in an array, we just need the brace expansion like before. But when the brace expansion refers to the name of the array without any index being specified, then it implicitly refers to the first element of the array. And keep in mind that arrays in Bash are zero indexed. So the first element is available at the index 0, the next at index 1, and so forth. So when the name of the array is referred to without any index, it always refers to the first element of the array or the index 0. So we get C back as C is the first element in this array here. And it is equivalent to using brackets and explicitly specifying the 0th index of the array. So to specify the index, a specific index that we want to get from this array, we just need to put the index number between brackets within the brace, the dollar braces for the variable expansion. And 0 refers to C, as in the case without the index being specified. And index 1 would be C++, index 2 would be Python, index 3 would be Bash, and so forth. It's also possible to refer to indexes with negative indexes, and the negative indexes start from the end of the array. So the index -1 refers to the last element of the array, which in this case is PHP. And -2 refers to JavaScript, which is a typo, and it gives an opportunity to override, to show how it's possible to override, for instance, an element of an array. So to override the 0, 1, 2, 3, 0, 1, 2, 3, fourth element, which is JavaScript here, or I can also use the -2 index and then override the value JavaScript properly written in this time. And then the index 2 refers now to JavaScript and not with my mistakenly written JavaScript. To print all the elements within an array in one go, it's possible to use the add special index in this case. So it's lang braces add, and then this gives back, this refers to all the elements of the array. So this will give the full list of the array. It's also possible, instead of add, to use star, and star also give the full list of the array. And the difference between add and star is that with add, each of the elements, there is a word split that happens, and with a loop we can access the individual elements of the array. We can loop through it. But with star, all the elements are returned as a single string. Associative arrays. Associative arrays are another kind of data structure that Bash offers for creating key value maps, which is known in Python, for instance, as dictionary, or more generally as hash tables. And to create associative arrays in Bash, we need to use the -a option, in this case A in uppercase, to indicate that we want to create an associative array. In lowercase, this refers to index array, like we've seen before. And for associative array, it needs to be an uppercase A. So to declare an associative array, here the user variable, that would be a hash map or an associative array, for instance, we need to declare the -a option, and then the name of the variable, I will just use lowercase, then parentheses. So the key value would be specified within the parentheses, and the key are defined between braces. So this associative array will have the key username set to the value Tommy, and the key group set to the value Dev. And notice that the pair of key value is separated by white space. So in this case, just a single space. And to access a key from an associative array, we just need to use the name of the variable followed by the key we want to access between braces, and the whole used with brace as variable expansion. So to access the username from this variable user, we just use $ braces, the variable user, set the braces, and the key that we want to read from the associative array. And then we get username Tommy. And to get the group, then we want to use the group key from the associative array, which in this case is Dev. To get the full list of all the keys available on an associative array, just use the $braces for variable expansion and the exclamatory character as the beginning to indicate that we want all the keys of the array, and give in the name of the array, and use the special index here to say all the keys. So this structure will list all the keys of the array user. In this case, our array have the keys username and group. And just notice that the order in which the keys are listed is not the same as the order in which we have set them in the first place. So basically, associative arrays guarantees no order. So in fact, the order is not important. The key can be get in randomly, in a random order. Unlike index arrays, where the order in which the elements are set into the array is exactly the same in which they can be accessed, yeah, from the indexes, for instance. Handling complex data structures with Bash. It's possible with the data structures that we have seen so far, like the reference to variables, indexed array, and associative array, to build more complex data structures to suit like specific needs. In this example here, we want to represent this dictionary of data on a user, for instance, into Bash, and there are different ways that this could be implemented. We have here as the data that we want to represent the name and the username, and those are strings, the age, which is an integer, languages, which are, let's say, a set of programming languages that the user masters, which is an array containing, in this case, C, C++, C#, Python, Java, and Ruby, and a set of version control platforms where the user is active, which holds, which is also an array, GitHub, GitLab, Bitbucket. So here is just an example of how it could be represented. There are different possibilities to represent this data structure, this data into Bash, and here is an example. So we declare the variable name and username as string, and we declare age as an integer using the -i option, and we declare the languages as an indexed array with the -a, lowercase a option, and we declare the version control platforms also as an indexed array with lowercase a -a option with the declare commands. So these are declared as separate commands, And then we declare an object variable that is here flagged with the -r option to make it read-only, the -a option to say that it's a read-only array, indexed array in this case, and the -u option to request bash to automatically convert every item in this array into uppercase, because the name of the variable has been declared with uppercase, and the values here are being specified in lowercase. So we can combine all these options together and say, okay, we want to declare a variable that is an indexed array, should be read-only, and each of its values should be in uppercase. So this is what this line is doing. And additionally, we declare a variable with the -n option, which is a reference. And we use this reference basically with a for loop to look through each of the items or each of the elements of the object array. So the $brace, the variable expansion with the dollar, using the object, which is the variable name here, and between the braces, the @index, which means all the elements of the array. And combined with the for loop, the variable ref will take for each iteration the values within the object array one after another. And this value actually refers to an actual variable, which means that with the reference, we can directly use reference to access the variable that is being stored at that under that name, and then print it. So this is what this example is doing and how it's representing this data structure into bash. For the purpose of the example, we will just implement it in a slightly different way. Let's say I create a shell script that I call data1.sh, where the goal is to represent the same data structure but using a slightly different method, right? Because apart from the languages and the version control platform entries, the 3 first entries can be represented directly in an associative array. So here we still need a way to represent this array into bash, and that's how we will see how we could achieve this. So first we could declare with the capital A option to declare an associative array, and we will just call it, let's say, object, like in the example before. Then we put the parentheses, and this associative array will have the key name that will be set to John Doe, would have a key username that will be set to Doe, and will have a key age that will be set to 35. So notice that with an associative array, there is not much flexibility to individually specify that age here is an integer. Yeah, but when declaring it separately, then we can explicitly label it as -a, which is, for instance, an extra that this way of implementing this data brings. But when we represent the 3 first elements together in an associative array, then this value 35, we cannot explicitly give it the integer attributes. But let's continue. Let's say languages, which will also be a key. And here as it's not possible to define such complex data structure directly, I will just use here a replacement and put languages ref to say a reference to a list of languages, and this reference will create it afterwards. So to make this stay on a single line, I will just create the one left the VCP separately on a separate line, and this also would be is also an array which cannot be directly created together in an associative array. So I will just call this version control platform ref as well. So here we have declared, let's say, more or less the data structure, because languages and TCP is still not explicitly declared. So here I have declared name, username, and languages together as associative array, and added the VCP extra afterwards. So far, so good. So now we will declare the languages ref, which is an index array, basically. Languages ref, and its value would be C, C++, C sharp, Python. Here, sharp is a special character for comments, so it's better to quote. C sharp, Python, Java, and Ruby. And this way we have declared the reference, at least the languages variable separately, of course. And then let's declare version control platform ref, include GitHub, GitLab, Bitbucket. So that's it. So far, so good. So now we want, let's say, to loop through all the data contained in our object, for instance. So with a for loop, we can get access to the keys, let's say key or key in, and to get the list of all the keys available in an associative array, we just use object. So this way. So dollar in braces for variable expansion, and exclamatory at the beginning to indicate that we want the keys, and between brackets at to indicate that we want the key of all the keys. So for each of the key, we want basically to print some information about the key, but we also want to handle the case when the key is a reference to an array, for instance, which the format that has been used is to append underscore ref after the name of the key, and this is implemented separately as an array afterwards. So we want to check if the name of the key contains I think for the implementation, I will actually do it the opposite way. The keys will not contain any ref. The values will not contain the ref, but the key, so that it's easier to check. So ref and the values themselves would be declared separately. Yeah, I think this way it's better. Then it would be possible to check if the variable key, we can use the regular expression much or the global much equal anything with ref, which means that if the variable starts with anything and ends with ref, then we want to do something with it. Yeah. So it means that it's an array, or at least in our example here. And if it's an array, we can print it conveniently. So we can use echo. I can first declare with the -n option to say that I want a reference, and the reference should be on a variable pointed by my key. So this way the key is a variable as well. I can quote this. So here we declare a reference, a variable with the -n option, which means that this variable is a reference to the object contained to the object referred by the key. And in this case, we will have checked if key ends with ref. So basically, every key ending with ref is actually contains a reference to a variable with the same name where the actual values are being stored. And with the reference, then we can do echo and print the key. Let's see. Key. And the reference will be an array, an index array. We want to print, let's say, all the elements of the array. So we will just use ref between brackets art, and this way we print. But if the variable does not end with underscore ref, then it means that it's just the other normal variables, and those we can print them out simply with e column, and then use the object and print the key. And that's it. So this way, the else case will print every other object, like keys like name, username, and age. And when the key ends with underscore ref, which means that the value contained is not the actual value, but the value is the name of another variable that contain the values that we want to print, then we declare a reference to that value. In case of language ref, it would be languages, and this reference would refer to this index array languages that we have created here. And for the case of the version control platform ref, E will refers to the VCP variable. And then we want to print all of them. So this, I'll save it, and then let's try to run it, see if everything was fine. So we have username, the VCP ref, print GitHub, GitLab, Bitbucket, the age 35, the language references, and the name. all good. And notice again that the output is in random order, yeah, because hash maps or associative arrays guarantees no specific order in which the values can be obtained. So here is an example of how a data structure can be created, and basically it would be possible, for instance, to create a linked list using this same structure. So let's say that we want to create a linked list which will contain some user information, and in the linked list there would be a next keyword that should refer to the next object into the list. So let's declare a sample of linked list. So let's have declare, have the -a option to create a set of users. Let's say this one is user one, and the user one will have actually the username, we would be John. Let's just say only the username for the purpose of this example, and we'll have the next key. I will always refer to the next user in the list. Let's say that it would refer to user2 because we want to have a user2. So I'll just duplicate and create a couple of users. And instead of using, I can actually just let it this way. So we have user2, user3, and user4. Op, mat. Let me it show so that all of them are 3 letters. So the user1 refer to user2, user2 to user3, to user4, and user4 there is no other user, so let's set this one to null. And let's declare a reference. Let's call it ref, and this reference refers to user1, like the start of the list. So currently it's being hard-coded. Yeah, of course, because I'm explicitly writing which user is coming in which after which one directly in the code here, but it can also dynamically be handled dynamically. So with a while loop, for instance, we can check if the referred to user exists, or if it has any keys. So for keys, I will need to add the exclamatory at the beginning, close, and then to. So basically this will check if the user being referred, the current reference or the active reference is non-null or has at least some keys. So in the case of the null string here, it will have no reference, So this will return an empty string, and then the loop would automatically end in that case. So for each, let's say we just want to print the username. So in this case, it's pretty straightforward since I'm not coding everything. So I will just for the purpose of the example, so we'll just put here username. So the username is printed. So, and we want to redefine the reference to the next one in the list. So this would refer to current ref, the next key of the current reference. So it will start by user one, it will print user one and reset the reference to user two, and then the loop will repeat till we reach null. And at null, there will be no keys at all because the variable simply does not exist, and then the loop will automatically end in that case. So let's save this and check this length list, it was called. So length list, oh sorry, hash length list. So it printed the name of the users in the order Joe, Tom, Bob, Matt, and at Matt there is no next element in the list, so it just ends simply. So this is statically coded, and it would be a nice practice to try to implement a function or write a small script that will dynamically handle this. You have to automatically create linked list and add new items into the list, or maybe even add new items after another, or even create a double linked list would be a nice exercise to try.